Alright guys, these are the solutions for the practice hack that I would have given to you earlier this week for your matrices. Remember that, just a disclaimer that I am actually going to be using the online matrix calculator because Toria has not been able to go back to school to sort things out for his own CAS calculator on my laptop. So yeah, unfortunately, the good thing is it basically does the same exact thing. So just use, if you can, your own calculator. But if you don't have that, then use the online version. It's called desmos.com/matrix. Yeah, just go into that. Really good and easy matrix calculator to use. Well, let's go through the first question here. I'm going to blast through these. So just fast forward through. If there are any questions that you already understand, then you don't need to watch all of them. Yeah, just the ones that you need to do. Let's start with the first one. A small city is divided into four regions: north, east, south, west. So NESW. The number of adult males and number of females living in each region is shown in 2013 is shown in this matrix below. So this column has all the males, this column has all the females, and the rows tell you the areas or the sections. So north, east, south, west. And there's your matrix. It is if you look at the order, so the first question is what's the order? So what's the row and columns? It is a 4 by 2 order matrix. It's 4 by 2. Easy. How many adult males live in the western region in 2013? So how many males? So we're looking at males in the west. So if you're looking at males, that means we're looking at the male column. And where is the western row? It's this row here. So 1850 males live in the western region. In terms of population of the city, what does the sum of the elements in the western column of matrix V represent? So this is saying if you were to add all of the elements in the second column, so I'm looking at the second column, which is here. So what does this number represent? So if you add all of these numbers, what does that represent in this matrix? Well, basically, if you're adding all of the numbers of females for each of these sections, that's what it tells you. So it's the total number, okay, of females, okay, living in north, east, south, west. So living in the region, the 4 regions. Now, it doesn't necessarily say that you have to tell me what the number is, but it's just asking you what does the sum of the second column represent. Okay, so it represents the total number of females living in the 4 regions. Next question. A school sells in the canteen pies, rolls, and sandwiches. The number of each item sold over the 3 school weeks is shown in matrix. So the columns represent the items. Okay, and the the column represent the items, the rows represent the weeks. So in week 1, this many pies were sold. In week 1, this many rolls, and this is how many sausages or sandwiches. Sorry. Okay, so in total, how many sandwiches were sold in these 3 weeks? So how many sandwiches? That means if we're looking at the sandwiches, we're looking at this column here, the third column. How many sold over the 3 weeks? So we're going to basically add 40, 60, 43, and 56. So I might just do that here really quickly. So 60 plus 40 plus 56 equals 159. So over the 3-week period, 159 sandwiches were sold. 159 sandwiches sold. Okay. The element of row I and column J of matrix M is Mij. So this is now looking at the specific elements in here. Remember elements, I think we looked this was in chapter 5a. But elements, I remember the numbers within the matrix. And Mij just basically represents when you see this little symbol here, it says Mij. It's basically just referring to the first letter is the row, the second letter is the column. So if you look at this Mi12, it's row 1, column 2. So what does the element in row 1, column 2 represent? So if you're looking at row 1, well, it's this row here. Column 2 would be this one. So it's this number here. So what does that represent? Well, it's the number of rolls sold in week 1. So 24, I'm going to write 24 rolls sold in week 1. You can write it any other way. You can say it represents the number of rolls sold in week 1, and then in brackets 24. Or if you just write 24 rolls sold in week 1, I would also be happy with that. Question 3. All right, here, a region has 4 districts, north, south, east, west. Okay, similar question to the question 1, I believe, or 2. Farmers from each district attend a conference in 2017. So there are farmers that attend some sort of conference from each district. Matrix F 2017 below shows the number of farmers from each of these 4 districts who attend the conference. How many of these farmers came from either north or the south district? So you're looking at now in the numbers or the elements here, how many are from N and how many from S? Well, you can see N has 36 and S has 20. 36 plus 20 equals 56. So 56 farmers came from north or south district. The number of farmers who attended the next year, which is 2018, increased by 25%. So there's been a 25% increase for each district from each year. Complete the product below with a scalar so that the product gives the number of farmers from each district who attended 2018. So this is saying now there's been a 25% increase. So if you want to increase all of these by 25%, remember the principle of how when you multiply any number with a decimal, okay, if it's a decimal number higher than 1, it's going to increase. If it's a decimal number below 1, it's going to decrease. So if it's a 25% increase, okay, that means you're going to, if you multiply anything by 1, so let's say 3 by 1, you get 3. It's the same. Therefore, this number has to be higher than 1 for that 3 to increase. Okay, now because it's percentages, okay, 1 basically, we've done this before, but 1 basically, if you think back to our recursion topic, it's going to be, if it's a 25% increase, you remember back to that rule where you've got R equals 1 plus that percentage over 100. Okay, that the common ratio. You don't have to think about it in that sense, but this kind of helps, I guess. So if you want to figure out what that number is going to be, 1 plus 25% over 100 equals 1.25, because it's a 25% increase. Okay, so that means that scalar number here, you're going to multiply it by 1.25 for the increase to go up by 25%. Okay, question 4, A and B are 2 matrices defined as below. Evaluate the, so you've got A, which is a row matrix, and B is a column matrix. So if I multiply A and B together, well, yeah, we'll see what happens. But here it says to evaluate the matrix product A and B. When you see product, it just means multiply. So that means we're multiplying matrix A and matrix B together. So I've already got my matrix A here, and this is my matrix B. So it's going to be A times B, and that equals 1890. Okay. Next one, determine the order of matrix product BA. Now, so if you multiply BA, see what happens. So you've got matrix B here. Oops. Okay, so let's clear this. Now, you probably think there's matrix B and there's matrix A. Now, remember, when you're multiplying 2 matrices together, the order matters. Because if you go B, okay, times A here, watch what happens. Okay, it changes it. Okay, it changes it. So it's A and B. A times B doesn't necessarily equal B times A, yeah? So in this case, B times A is the, if you write down the orders of it, so B matrix is a, okay, just give me a sec, guys. Okay, guys, so sorry, you probably heard that. There was a student that asked me for help, and she had music happening in the background. All right, let me get back into this. All's up to part 2 of question 4. Determine the order of matrix product BA. So the order for B, it's got 4 rows and 1 column, so it's a 4 by 1. And the product for matrix A is a 1 by 4. Okay, which means that when you multiply them together, remember when you the order matters, yeah? So when you multiply them together, you can see that the outside numbers tell you the order. So it's a 4 by 4. So 4 by 4. Matrix A displays the number of servings of 4 foods: bread, margarine, peanut butter, and honey, needed to make peanut butter and honey sandwiches. Okay, so it displays the number of servings of the 4 foods. Okay, matrix B displays the energy content per serving of the 4 foods: bread, margarine, peanut butter, and honey. Explain the information matrix given that that matrix AB provides. Okay, so a matrix A represents the number of ingredients, okay, to make certain sandwiches. So 2 for this sandwich, 2 for that, 1 for this, 1 for that. And then here represents the calories or the energy for each of those items. Okay, so when you multiply A and B together, so A times B, so if this is the number of items for that sandwich, or the number of servings for the 4 foods, multiplied by the energy content or the energy content for each of it, if you multiply them together, what does it give you? Well, basically it gives you the energy content, or the total energy content, okay, for the 4 foods. Okay, so when you're multiplying the 4 foods times the energy content, well, we multiply them together, it gives you the total energy content for all of those 4 foods. Okay, question 5. A manufacturer sells 3 products, A, B, and C, through the outlets of 2 shopping centers, Easttown and Knoxland. Okay, the number of units is given in this matrix. So here, A, B, and C is the number of items sold. So A has this many items, B has this many items, C has this many. The rows represent the area that they were sold in. Okay, matrix P shown below gives the selling price in dollars for product A, B, and C. So A costs this much, B costs this much, C costs this much. So each A item will cost you $14.50. Each P item will cost you $21.60. Each C will be $19.20. Evaluate the matrix M, where M equals QP. So if you multiply Q times P, so this is the number of items multiplied by the cost for each item. Okay, what is it going to give you? Well, it's matrix M, and what does that provide us? Okay, I'll answer that in a second. But evaluate M, a matrix M, which is QP. So matrix M. So I can already tell matrix Q, okay, is a 2 by 3, and matrix P, okay, is going to be a 3 by 1. That means the order for your answer is a 2 by 1, yeah? 2 rows, 1 column. So it's a 2 row, 1 column matrix. And what that will give you is the total amount for the E's and the total amount for the N's. So let's evaluate that here. Okay, so I've got matrix Q and matrix P. Okay, I'll leave that. So matrix Q times P, so Q multiplied by P will give us that number. So 145978. So that's telling me the total amount in terms of how much money was made in all of the E, and the bottom one is 171849. The total amount for all the items sold in N. Okay, in Knoxland. So what does the elements in this matrix provide us? It tells us the total amount of money made, I would say, or the total, let's say, yeah, the total the selling price. So let's say the total earnings made for each town. Okay, because it tells us how much how much was sold in each town, which is there, the rows there. Explain why PQ is not defined. So if I try to do P times Q, remember matrix P, okay, over here, matrix P, okay, if you can see, has 3 rows, 1 column. matrix Q has 2 rows and 3 columns. So if you think about, again, order, matrix P is a 3 by 1, and then matrix Q is a 2 by 3. Notice how the middle numbers are not the same, which means they can't be multiplied together, yeah? So if you go in matrix here, P, oops, sorry guys, P times Q, it's impossible to do. Okay, not defined. So you would say, because, okay, if you look at the middle numbers, the row, the columns for the column for matrix P, so P, this matrix, this is P matrix, this is Q matrix, does not match or does not equal, or you could say, or match the rows for matrix P. Oh, sorry, matrix Q. Okay, easy. Question 6. Okay, so matrix F here shows the flight connections for an airline that serves 4 cities, A, B, C, and D. I won't have to say the names there. And it says here, look at, just try to understand how this matrix also works here, guys. See how it says from is at the top and 2 is here. So that means we're going to read this as from B to A, C to A, D to A to B, B to D. Okay, for example, it's not going to be B to B or A to C. So it's this. Just understand where it's from and where it's to. So you start from here and you're going to this. Okay, so in this matrix, the one in the column for C row B, in the one in the column C row B, so column C row B, this one here, for example, indicates that using this airline, you can fly directly, I'm assuming that's what it's going to say, from Cantor to Berger, so from C to B. The 0 in C to D indicates that you cannot fly directly. Okay, so remember that the 1 represents that they can communicate to one another directly. 0 means they cannot communicate to each other directly. Complete the following sentence. On this airline, you can fly directly from Berger to something and something. So if we're going from Berger, you can fly directly to, you can see that you can go straight to A in this case, well, what is A as an anvil, and you can also fly directly to, so from B to D which is downtel. Easy. Next, evaluate the product matrix G, where KF represents G and K matrix is 1, 1, 1, 1, 1. Now, this is a row matrix. Remember what your row matrices do, okay? So when you multiply something with a row matrix, okay, understand where you need to put it and also what it does for you. So if you multiply all of this with a row matrix, it's going to be K, which is this matrix, 1, 1, 1, 1, times F. So if you go all of this row times column, row times column, row times column, it's going to add up all of these numbers. So it's going to give you the total for each column here. And what that does is it gives you the total number, obviously, the total number of direct pathways from and to. So total number of direct pathways from A to everyone else, B to everyone else, C to everyone else, and D to everyone else. So if you do that here, matrix K, I've done that for you already. Oops, capital K. And matrix F, I've got that there. So it's asking us to evaluate K times F. So when you evaluate that, K gives you that matrix. So 1, 2, 1, 1. So matrix G, 1, 2, 1, 1. And this is A, B, C, D. And remember, what does this information contain? Well, it tells you all of the direct paths or the direct paths that basically each of these airlines can take to another person. So A has only one direct path to every single other area. B has only 2 direct paths to every other place. C has 1, D has 1. So the direct flight path from each location. That's what this is telling us. Location. Okay. All right, question 7. 2 subjects, biology and chemistry, are offered in the first year of a uni course. Matrix N lists the number of students enrolled in each. So here, you got matrix N. The column would tell you how much students there are altogether. So if you added all this up, number of students altogether, rows will tell you how many in each class or each subject. Matrix P lists the proportion of these students expected to be awarded A, B, C, D, or E. So in terms of grading, that's what they might get. Write down the order of matrix P. So what this is saying is how many students will get an A, how many will get a B, how many C, how many D, how many E. Okay. All right. So in terms of the order of the matrix, what's the order of matrix P? Well, how many rows, how many columns? I can see there's only one row. And how many columns? 1, 2, 3, 4, 5. 5 columns. Let matrix R represent NP. Evaluate matrix R. So this is now saying we want to evaluate N times P. All right, so on my matrix here, there's matrix N, there's matrix P. Okay, evaluate N times P. And what do you think that might represent? Matrix R. Well, in the context of this, when you multiply N and P, remember N represents the number of people or the number of classes and how much in each class. P represents the grade, okay, or how much people will get an A, how much people get a B, C, and D. So when you multiply them together, okay, it will tell you the grades to the number of people who will get an A in biology, number of people who will get a B in biology, number of people who will get C, D, and E, and also the number of people who will get A in chemistry, number of people who will get B in chemistry, C in chemistry, D in chemistry, so on and so forth, okay? So let's evaluate N times P. N times P, okay, right there, matrix R. A lot of numbers, but 23, 57.5, 80.5, 207, and then 92. Let's choose another color so people don't get confused. 18, 45, 63, 162, and 72. Remember, these rows represent the subjects. So this is biology, and this was chem. And like I said, each column, remember, will represent the marks that each person will get depending on that class. So according to this, let's use green. This is A, this is B, this is C, D, and E. And you can see here that 23 people in bio would get an A. 57.5 people in bio would get a B. 45 people in chem would get a B. So in this case, what does this represent? What does this element, R24, so row 2, column 4, row 2, which is the bottom row, column 4, which is this column here, what does that represent? Well, it represents, okay, the number of people in chemistry who would get a D. So the number of people in chem who will receive a D. And you can write the number as well, it's 162. Because it's 2 marks for that question, I think it's a good idea to also write the number, because it's probably going to, 1 mark would probably be the explanation, the other mark would be the actual number. Okay, students enrolled in bio have to pay a lab fee of 110, while students in chem will pay a lab fee of 95. Write down a clearly labeled row matrix called F that lists these fees. Okay, so basically it's a row matrix. That means it's going to have 1 row and 2 columns. We're going to call this matrix F. Okay, and we're basically going to write down the elements that it gives us here. So for bio, which is this column, you're going to have 110. And for chem, which is this column, 95. Okay, Show a matrix calculation that will give the total fees paid in dollars by the students enrolled in both of those subjects. So if matrix F gives you, okay, the cost for each, the lab fees for each subject, and matrix matrix N here, remember, is the number for each student in those subjects, what will the product give us? So basically what we're going to do is F times P. So F times N. Okay, and this is saying it wants us to figure out how much each, what's the total cost for the whole subject, or for all the students if they were all to pay the lab fees. So matrix F, 110, 95 multiplied by matrix N, which is 460 and 360. So when you multiply them together, F I've already done here, I believe. Oh no, I haven't. I'm gonna make a new F matrix then. This has one row and two columns, and you have 110 and 95. Okay, I've just called it C. Sorry guys, it's called matrix C now. I should call it F there, but just please don't get confused. It's called matrix C, so it's now C multiplied by N. Okay, and then when you multiply them together, it gives you the total 84,800. Okay, that all the students actually, when you add them all together, how much they'll all pay for the labs for chem and bio, or bio and chem. Okay, let's move on. Rosa uses the following 6-digit PIN number for her bank account 216342. With her knowledge of matrices, she decides to use matrix multiplication to disguise this PIN number. Okay, now this is now referring to encoding and decoding. Okay, first she writes the 6 digits in her matrix, in a 2x3 matrix. So 2, 6, 4, 1, 3, 2. So this is her 6-digit code. Okay, then she creates a new matrix by forming the matrix multiplication C, which equals B times A. So she wants to encode her message 264132. So her code, remember, was 216342. So 216342. That's her code. It's not 264132. Sorry, 216342. That was her code. 216342. And she wants to encode this so people don't know what her actual PIN is. And so she's going to use this matrix, which is your encoding matrix, to encode that. So determine matrix C, which is B times A. So that's going to be this matrix, B, times A matrix, which is that. Okay, let me see if I've actually done that here. B. Yes, I have. There's B matrix. There's A matrix. So we're going to go B multiplied by A, and when you encode it, B times A, okay, that gives you 1, 3, 2, 3, 9, 6. So according to the encoded message, her code is 133926. So no one can actually now know her code. From the matrix C, Rosa is able to write down a 6-digit number that disguises her PIN. She uses the same pattern to create matrix A from digits 216342. Write down the new 6-digit number that Rosa uses to disguise her PIN number. So the new PIN number, okay, that she now has is 133926. Okay, which is obviously not the original number, which is that one. Okay, and now show how the original matrix A can be regenerated from matrix C. So now we have to decode this matrix. So in order to decode that matrix, remember, we get the coding matrix and we inverse it. So we're going to go the inverse of B multiplied by that matrix there, matrix C. Okay, to decode her PIN number. So remember, this was what B times A gave us this matrix, which is represented by matrix C, 133926, and we need to decode that. So in order to decode that, we need to inverse B. Okay, so if you inverse B here, oops, B inverse. So B inverse. There's my inverse of B. So -1, 1, -2, 1. Multiplied by my matrix C, which remember C was the encoded message. So 133926. 133926. And if we've done this correctly, it should give us or put us back to this point. 216342. So if we do that properly, B inverse multiplied by let's see, matrix C. Did I don't think I made that here, but I'm just gonna add, let's call it matrix C. Okay, matrix C is already taken in this, sorry guys. So I'm just gonna go, I'll call it D. Hopefully people do not get confused with this. So 1, 3, oh sorry, forgot to add another column there, 2, 3, 9, 6. Okay, so that's matrix. Well, in this case, it's called D, but just know that it's this matrix here. Yeah, guys? So we're going to go B inverse multiplied by D. So it should bring us, remember, if we've done this correctly and you multiply them right, it should bring us back to the original point of this matrix. Okay. It should bring us back to this point, 216342, because we are now decoding that matrix. And we got that right. So 216342. That's correct. Okay. All right. Let's go to the next question. Question 9. And we. All right. Question 9. Consider this matrix equation. Okay. So this is easy because it's already broken up everything for us into its number matrix, letter matrix, answer matrix. Okay. But in this matrix, A refers to the cost of 1 pie, B is the cost of 1 roll, C is the cost of a sandwich. So A, B, C. Now, obviously, remember when you break this up, we're not quite done here yet, yeah, because we're going to try and figure out probably what is the cost of each one of these items. Now, in order to do that, when you have a question like this, remember you got to get this matrix, bring it on the other side, inverse it, and then multiply it with the answer matrix. So it's going to be, I think I've called this matrix A. So you're going to inverse it, multiply it with this matrix to figure out what A, B, and C are. Okay, so I've done that here already. A matrix inversed, so to the power of -1, multiplied by B matrix. And there's my answer. So when you do that, A matrix, this matrix here, inversed multiplied by that. So what is A, B, C? Well, A is 4.65, B is 4.2, and C is 3.8. So what in the question here, what is the cost of 1 sandwich? Now just look at the question according to this. Okay, C refers to the cost of sandwiches, so that means 1 sandwich right there costs $3.80. $3.80. 1 sandwich. Easy. The matrix multiplication below, the matrix below shows the total value of all rolls. I think if they forgot to put pie here as well. Pie, rolls, and sandwiches sold in the 3 weeks. So that means when they, if you have this matrix here, so this final matrix here, and this matrix calculation here shows the total for all of them. So L times something gives you the total of all of them. So it's basically just added all these up. Matrix L is an equation of this. Matrix L in this equation is of the order 1 by 3. So that means in matrix L has 1 row and 3 columns. Write down what matrix L is. So what matrix L has done is it's just added all of these up. So it's basically a row matrix. Remember what row matrices do and what they look like? Row matrix is able to add up all the columns. So that means all the elements in this matrix are just 1, 1, 1. Because when you multiply all these, so this row times all these columns, it's going to be, it's just going to basically add each of these items. Okay, so matrix L, there's your matrix. is a 1, 1, 1 row matrix. Question 10. Three farmers, each from farmers A, B, and C, are placed orders of three types of fertilizers in their cornfields. The types of fertilizers K and P are here. So each farmer orders row refers to the farmers, and the column refers to what they each ordered. Let X be the price per ton of calm, Y be nitro, Z be the price for each fate. The total cost of the two orders can be summarized by the matrix equation. Okay, over here. Explain why this equation cannot be solved using matrix inverse method. Now, the really simple answer for this and why it cannot be done is if you look at this matrix, okay, this is a 2 by 3 matrix. Remember that when it comes to doing these kinds of equations, especially with inverse matrices, so if you look back at your notes for inverse matrices, you can only do an inverse matrix when it's a square matrix, which means that there's the same number of rows and the same number of columns. So if I try, for example, here, I'm just going to make that matrix. So you've got 2, add another column. So you've got 2, 4, 2, 2, 5, 1, 2, 5, 1. Okay, there's my matrix. See, you can't actually find an inverse of this, and you'll see. C inverse, it's impossible to do. Okay, there's no answer for it because it's not a square matrix. Okay, it doesn't have enough. There's not enough rows here. Okay, you need to be able to. You need basically one more equation to be able to do. Find out what the actual price is. So it cannot be solved. Okay, cannot be solved. Sorry, why is it doing that? Okay, cannot be solved using matrix methods or using inverse method. Okay, because this matrix here is not a square matrix. Okay, so I would write something like the matrix that has been given is not a square matrix. So or you could say the first matrix or the number matrix. Let's write that here. Is not a square matrix. Remember, if you look back at your notes, you can only do inverse operations if the matrix is not a square matrix. If the matrix is a square matrix, it has to be a square matrix, okay, in order to be able to do an inverse of that matrix. Okay, last question here. Market researchers claim that the ideal number of bookshops, X, sports shops, Y, and music stores, Z, for a shopping center can be determined by the following equations. Okay, now we've got here, okay, I can see a equation where you can actually now use the inverse, yeah? But when you get an equation like this, remember you need to split it up into the number matrix, the letter matrix, and the answer matrix. So let's split that up. Remember, the rows are the equations, the columns refer to the letters. So in this equation, I can see the first equation, okay, there's two x's, so 2 for the x, y, there's going to be 1y, z, there's going to be 1z. Okay, remember, in front of these letters, there is a 1. Second row, second equation, there's going to be 1x. And over here, there's a 1 there, so that's a negative 1. Okay, and in front of the z, there's a 1. Third equation, okay, there is no x's that it starts off with, so there's going to be 0 x's. There are 2 y's there, and there's a 1 in front of that z, so it's negative 1 for that third row, third column. And then you got x, y, z for the letter matrix, and then the answer matrix, 12, 1, and 6. Okay, easy. Do the equations have a unique solution? Provide an explanation to justify your response. Well, does this have a unique solution? Now, in order to answer that, all you have to do is think about, you got to look at the matrix here, and are we able to find an inverse for it? Okay, that's what this is asking. If you can find an inverse for this matrix, then there is a unique solution. Okay, so if you look at matrix, I'm going to call this matrix A. I've called that A here. Yeah, there's matrix A. Oops. Okay, there's matrix A. Is there an inverse for matrix A? Yes, there is. Okay, so yes, there is a unique solution. Because, and why is that? There is oops. So because I'll say an inverse is defined for matrix A, and my matrix A is this matrix here. Yeah, so an inverse is actually doable. Another thing you can also do is you can also calculate the determinant for it. So if you write determinant for A, if it exists, then it definitely, it's definitely a unique solution. Remember, if the determinant is 0, then there is no unique solution. Yeah. So I would also write here the determinant for A is 1. All right. So also mention that, please. That'd be a good thing to mention. Write down an inverse matrix that can be used to solve these equations. So basically, we're just going to find the inverse of A. So A inverse. Okay, right there. So the A inverse is that. So there's -1, 3, 2, 1, -2, -1. Oops. And you got 2, -4, -3. And then solve the equations and hence write down the estimated ideal number of bookshops, sports and shoe shops, music stores in the shopping center. So basically, we're just going to now solve this equation. So I've got, remember, to solve it, you're going to get that matrix, inverse it, multiply it with the answer matrix. So you've got X, Y, Z. Okay, and then you're going to inverse the A, which I've already got there. And then you're going to multiply it with the answer matrix. So A inverse is -1, 3, 2, 1, -2, -1, 2, -4, -3, multiplied by my answer matrix, which I got was 12, 1, 6 there. 12, 1, 6. Multiplying that should now give me the amount for each shop. Excuse the handwriting. I'm actually rushing this to finish this for you guys. Oops. Multiplied by matrix B. And that gives us the answers 3, 4, and 2. That means we need to have 3 of the bookshops, 4 of the sports shoe shops, and 2 of the music shops. Okay, hope that's all made sense to you guys.